Okay, so in the previous video I left off with talking about the test for invertibility. So using the horizontal line test, we notice that this function here crosses the graph at 2 points. This line crosses the graph at 2 points, so it is not invertible, meaning that its inverse is not a function. And that creates a problem because now we're trying to find the inverse of this parabola. We cannot. And the solution to that is we can restrict the domain. So how can we choose just part of the graph such that it now passes the horizontal line test? So when we're talking about parabolas, it was easy because we can just take this parabola and say we don't want the entire parabola, we just want part of it. So we just want part of it, what part do we want? Well, we go ahead and cut the graph in half. So if I just take this right hand side and say that now my domain is from 0 to infinity, or x is greater than or equal to 0, then I've essentially cut off part of my graph, and now my graph is only that red part. So because of that, when I do the horizontal line test now, since it's only the right hand side, it's only the red part, now it passes the horizontal line test, and now its inverse is a function. So since this is my only part of the graph, when I find the inverse of it, I notice that here's my inverse, and yes, this passes the vertical line test. So yes, my inverse is a function. So that's how we restrict the domain. Now I'm going to go ahead and bring us back and tie all of this information about inverses to our Unit 6, our trig function unit. So let's go ahead and start talking about the inverse trig. Inverse trig function. Okay, so the whole reason for why we're learning about inverse trig functions is this whole time we've been trying to find the height on a unit circle. Say for example sine. So sine of what angle? Sine of an angle is equal to a height. Well, the question is, what is the height? So we're always given an angle. So say for example sine of 30 degrees. And then we have to go look for the height. But what if we know the height, but we don't know what the angle is? What if what we're trying to find is not the height, but what if we're trying to find the angle, and we're given the height? Say, for example, the height is √3/2. So based on what you already know, you can go back to the unit circle, look for √3/2, figure out what angles you need. But in certain cases, we also don't have the special right triangle tools that we can use, so we're going to introduce this new notation called inverse trig notation so that we can plug it into our calculators and also find the answers. So let's go ahead and talk about inverse trig functions. So I'm going to introduce this by going over our sine function one more time. So in our sine function, when we have our input of x, our function here is sine of x. So I'm going to just give you a couple of points as an example. So you guys already know that 30 degrees of sine is equal to 1/2. So sine of 30 degrees is equal to 1/2. The height is at 1/2 when our angle of rotation is 30 degrees. And 30 degrees is also pi/6. So don't forget, those two representations are the same thing. So let's do another point. Well, 60 degrees, which is pi/3, our height there at that point on the circle. 60 degrees right here is √3/2. Let's do another angle. 120 degrees, which is 2pi/3, is also at √3/2. So it is right here. And let's do another point, 150 degrees, which is 5pi/6 radians, is at the height 1/2. So here's 150, our height is at 1/2. Here's 30 degrees, the height here is at 1/2. Okay, so if you don't remember how to find these values, go check your unit circle. And I want to show you that sine is a function. So if we go ahead and plot these points, you guys already know that the sine function looks something like this, where this is 1, this is -1, this is 90 degrees, this is 180 degrees, sorry, 180 degrees, this is 360 degrees. Okay, so And that looks fine, because if we use the vertical line test here, we know that our sine is a function. Sine of x is a function. And the reason it's a function is for every degree, for every angle of rotation, we have exactly one height. You cannot have multiple heights at the same angle of rotation. But if we go ahead and take a look at a horizontal line test, we notice a problem. So here's our horizontal line test. And we notice that every time we draw a horizontal line, it passes through at least 2 points here between 0 and 360. And if you remember back, our sine wave actually goes on forever. So this wave continues over and over again. So for a given height, we hit that same height many times, actually an infinite number of times. And even in our chart, we realize you'll see that at the height 1/2, we pass through it at 30 degrees. At 1/2, we pass through it at 150 degrees. So we already know that sine is a function, but it is not invertible. So it is not invertible. That means sine does not have an inverse function. Well, that's a problem. So in order to correct this problem, just like our parabola in the previous example, we're going to restrict the domain. So how do we restrict the domain to our inverse function? What do we want to restrict it to? So if we take a look at this graph right here,